So now we're going to talk about undesirable redox reactions. These are known as corrosion. Metals exposed to oxidizing agents in the environment will gradually undergo redox reactions. Well, the metals are oxidized. And that can have some pretty negative effects on whatever you've made out of that metal. Oxygen is easily reduced, and it can bring about the oxidation of other substances, and oxygen is present in the air, right? So the corrosion or oxidation of most metals is spontaneous when paired with the reduction of oxygen, which is why you don't find very many metals as pure metals out in the dirt. And yet we still use metals to build things, right? Some metals, like aluminum, end up protecting themselves. So aluminum, as it oxidizes, forms Al2O3, which is very inert and structurally solid and acts as a protective coating. So no further oxidation will occur. This also means that, your aluminum pan is going to get this coating on it, and you want to leave the coating. You don't want to polish it off because it'll just keep corroding. Cast iron skillet, is worse, and that's why you need the grease, basically, polymer on there. So aluminum kind of takes care of itself. Iron doesn't work that way. The oxides that it forms tend to be flaky. That's what rust is, right? Tend to be flaky, and they fall off, right? Exposing more iron, and so more oxidation can occur, more rusting. So this is at the same time kind of fascinating and confusing. So this is looking at what happens as iron rusts. So here we've got a building with iron siding on it, right? And you really need some moisture in order for this to happen. So here we have a water droplet, and we have, this is the iron. And so we've got iron being oxidized to iron 2, and that gives off 4 electrons. And then that, what the heck? It sets up an electrolytic cell within the water, a voltaic cell within the water droplet. And so you end up with the rust being formed and the metal being eaten away. There's hydrogen ions that take part in this rusting, and those are naturally present in water, even more than just the self-ionization of water, but because of carbon dioxide that's dissolved, forms carbonic acid. And so the iron 2 ions can travel through the surface moisture. This is the anodic region, this is the cathodic region. So they can travel over here, and this is where they form Fe2O3. So what rust is really is a hydrated form of iron 3 oxide. And it's not a pure substance, though. The composition of it can vary. It could have different amounts of waters of hydration, and you could conceivably also get some mixed oxidation states for the iron. So we need moisture present for oxygen moisture present for rust to happen. Because water is a reactant in the last reaction of that, and we must have charge that's able to flow, and so the water provides a medium for the charge to flow in. If there are electrolytes like salts in the water, then the rusting occurs even better, right? So I grew up in the Midwest where they salt the roads in the winter, and when you drive your car, the salt gets on your car, and so it's very common to see cars where the lower panels were just like completely rusted through. We call them rust buckets, right? And you come out to California and you just don't really see that very much, unless you go to the coast. If you've got a car at the coast, you can have some trouble too, because the seawater mist has salt in it, and that can contribute to the rusting. Acids will also promote rusting because hydrogen ion is one of the reactants as well. So how can we prevent corrosion? There's actually a whole industry around the prevention of the rusting of iron. Well, keeping the iron dry is essential. How do you do that? Well, one common method is to paint the iron. If you paint the iron, the paint acts as a barrier and keeps the water away from the iron until you chip the paint, right? Another way is to put a sacrificial electrode in contact with the iron, and this is an illustration of that. So we have an iron pipe here, and we don't want the iron pipe to rust, so we're going to connect the iron pipe to something that will oxidize more easily than the iron. And so it's like, no, here, have this one instead. It's the sacrificial electrode, right? Now, eventually, the sacrificial electrode is going to rust away, and you'd have to replace it, but that can work. You can also coat the iron. This is basically coating the iron with a sacrificial metal, a metal that oxidizes more easily. And this is what galvanization does. So galvanized nails are coated in a thin layer of zinc. And so the zinc will oxidize, and the zinc oxide is actually nice and sturdy like aluminum oxide, and so it will remain there and serve as a protective coating for the iron nail underneath. So, you're building a fence outside, you want to use galvanized nails, right? Inside, maybe you could use, just plain old iron nails if they're not going to get wet. But your fence will just, those nails will just rust away outside. Any questions? Yeah.
Does that structure of a water droplet causing a cell happen for all forms of rust, or not rust, but all forms of corrosion?
Yeah, I think it would. Only the spontaneous ones are going to happen, but the water is definitely going to contribute to that. Okay, so which of these metals does not act as a sacrificial electrode for iron? Well, what do we need to know? We need to know relative potentials for these guys. So we'd have to look in a list. It's copper.